Finding Least Common Multiples or Least Common Denominators with Paul Kopko. In this video, you're going to learn an easy and foolproof method to find least common multiples or least common denominators. A least common multiple is the smallest number that a target number can divide into. If your target numbers are on the bottoms of fractions, in other words, denominators, then we're talking about least common denominators. But the method I'm going to show you is exactly the same for both. Let's say we're given a problem of finding the least common multiple of 54 and 36. 54 and 36. So we want to find the smallest number that these two numbers will divide into. Now, first we're going to follow the 5 steps from this method over here. The first step says to use the string factoring method on each term. Now, the way that works is this. We draw what looks almost like an upside down division symbol here, which is like this. And actually what we're doing is kind of dividing upside down. We see that this number is even, so we try to find the smallest number that we can divide into this. And it turns out that because it's even, we can divide 2. 2 into 54. 2 into 5 is 2. 2 times 2 is 4. 5 minus 4 gives us a 1 right here. And so that gives us 14. So 2 into 14 is 7. Now we try to find the lowest number that will divide into this. And we can't use 2 because it's not even, but it looks like we can use 3. 3 into 27 is 9. And again, we want to find a number that can divide into 9, and it looks like 3 will work again. 3 into 9 is 3. Okay, now let's do the same process here for 36. It's even, so we can do 2 again to start with. 2 into 36, 2 goes into 3 once. 1 times 2 is 2. 3 minus 2 is a little 1 again. And so we have a 16. 2 into 16 is 8. Still even, so we can divide by 2. 2 into 18 is 9. And here we go with 9 again, which means we divide 3 into 9, and we get 3. So this is step 1 up here. Use the string factoring method on each term. Now we're going to go to step 2, and step 2 tells us to list out each string of factors. Now let's see what that means. It means first we're going to take our first number that we have in our problem here, which is 54. And we're going to list out the string of factors that we developed over here. So we have a 2. That's this one. Then we have a 3, so that goes here. And we have another 3, so that goes here. And then we have another 3, so that goes here. So here's our list of factors right here. Now, we're going to list out the factors of 36, but we're going to do it in a little bit special way. And step 3 here says stack string factors. Now, what that means is this. As we list out the factors for 36, we're going to look and see if there's a matching one in the string here for 54. So our first one here is a 2. And yes, there is a 2 in the top string here. So the second 2 goes directly beneath it in a stack. Okay, our next number here is another 2, but there are no more 2s up above. So there's nothing that we can stack it under. That means that it's going to get its own column over here at the end. Over here we have a 3, and sure enough, there's a 3 on top, so it will go directly underneath. And then finally, we have a 3 again, and we do have another 3 up here, so that will go directly underneath. Now we're going to do this. Okay, now we look at our step 4, and that says bring down columns. Now what that means is that we're simply going to copy these columns straight down underneath. So for the first one, which is right here, we bring these down like that. The next column is right here. We bring down this stack of 3s. For this column, another stack of 3s. Here we see that this 3 got its own column because there were no other matches for it, but it still gets brought down just like the rest. And the 2 here has its own column as well, so that gets brought down the same way. Now step 5 says to multiply the factors together, and that just means this. We put multiplication dots in between here, which means to multiply these guys together, and we get our equals out here. So let's see, we need to multiply 2 times 3, take that answer, multiply it by 3, take that answer, multiply it by 3, take that answer, multiply it by 2. However, we could go ahead and combine these factors in maybe a little bit easier fashion. For example, like this. Here's 2 times 2, which is 6. Here's 3 times 3, which is 9. Then if we want, we can multiply 9 times 6. 6 times 9 is 54. And then our last factor here is the 2. So we could go ahead and multiply 2 times 54 for our final answer. And 2 times the 4 is 8. And 2 times the 5 is 10. And there's our final answer, 108. So what does this mean? This means that for the numbers 54 and 36, 108 is a least common multiple. That means that 54 can divide into 108. In fact, it divides in twice, as we see right here, 2 times 54. But it means also that 36 can divide into 108. And if we take a look here, suppose we do this. If we multiply 36 by 3, 3 times 6 is 18. Put down the 8, carry the 1. 3 times 3 is 9, plus the 1 is 10. So sure enough, 36 divides into 108 also 3 times. So this is a foolproof method that will always work. And these are the 5 steps to carry out. First of all, we use the string, what I call the string factoring method, which is kind of like upside down division. And you develop here a string of the lowest possible numbers, or in other words, prime numbers, that can be divided into your target number up here. And then we do the same thing for here. If you have 3 numbers, you would do another number and do another string. Then you would list out each string of factors that you found up here. The first string you would just copy right out. But in the succeeding strings, whether you have just one more string like we had here for 36, or whether you have many other strings, each time you list out those strings, if there's a matching factor that's already there, you would put it underneath to create a stack. If there's not a matching factor, then it gets its own column out here at the end. Then number 4 up here says bring down the columns, which means just go ahead and copy these guys all down. And finally, multiply factors together. Just means that once you get these guys at the bottom, multiply them all the way across, and you will get your least common multiple. Now, if we were talking about fractions that had these numbers on the bottom, 54 and 136, suppose we had a problem like this, 1 over 54 plus 1 over 36. Now what we see down here are denominators, the bottoms of fractions. And of course we could not add these 2 fractions together until we have a common bottom or a common denominator. So we've already determined that. So the way we would do this would be just to do equals. And down here we're going to have 108, which is our least common denominator. In this case now we're talking least common denominator. And then over here we're going to have that also. So here's how this works. We say, what do I have to do to 54 to get 108? And the answer is, as we saw up here, you have to multiply it by 2. So that means I would multiply this by 2 to get the 108. But what that means also is I have to multiply the top of the fraction also by 2. And multiplying by 2 over 2 is the same as multiplying by 1, which will not change this number. Next, we would look over here and say, okay, what do I have to do to 36 to get 108? Well, as we saw right here, we'd have to multiply by 3. So if we're going to multiply 36 by 3, we would also multiply the top of this fraction by 3 as well. 3 over 3, which again is 1. So now over here, we've got 2 times 54 gives us the 108. 2 times 1 up here gives us 2. Down here is the 3 times 36 is 108. And now we multiply this top by 3, and we get a 3. And we wind up with a final answer here of 5. Now we just add the top terms over 108. So there it is. This process will always work even with more complicated expressions than just numbers like 54 and 36. But I'll show you that in another video. Thanks for watching.